Hi guys, welcome to DURGASOFT project world. Today I am going to discuss about a topic like self-interested routing in online environments. Self-interested routing in online environments. Self-interested routing means based on my interest. Suppose I am the network. As a network itself, we have one more terminology, that is routing. Why means as a network we have a group of systems. In generally we are transferring the data from one system to another system based on the some routing mechanism only. So if you want to avoid the data collision and data losses and the data hiding, all these things, and to protect the data transformation from the hijackers or all whatever the mechanism you can take, all the data transformations should be processed with the routing only. From past decades, from 10 to 20 years, whatever the data transmission started in the networks, since then the routing procedure is changes in a lot of ways. Currently we are working on the routing channel. Based on the host itself can take the directions based on the traffic or based on the availability of the resources based on the network. So based on that only the host itself can take it directions to route the data transformation. But here we have some of the little bit of disadvantages or some of the problems where we are working in the even our latest advancement. We have to be studying this paper. So what we are doing is, in generally we are working on the self-interested routing in nowadays, very advanced thing. So based on the self-interested routing, okay, we are applying that routing technique in online environments, in internet based applications, internet kind of network topologies. We are applying those self-interested routing. So how it will be happen, whether it may be a good, whether it may be a bad, how the results are look like, everything we have to find out in the paper which you are going to be described in today's. Okay guys, we are applying self-interested routing in online environments. Self-interested routing means itself it can take based on its interest, the routing will be happens. The host who is managing all the data networks, that host will take a directions. Check out a recent trend in routing research is to avoid inefficiencies in network level routing by allowing hosts to either choose the routes themselves, okay, or use overlay routing networks. Nowadays, to avoid the inefficiencies in the network, we are following two things. Either we can choose the routes by themselves, means the network, whatever the channel we are processing, the network itself it will guide the route of the data transformation, or we are using overlay routing networks. So we are, for routing itself, we are taking one more network to guide the data transformations. Either any one of the way you can use it, okay, but the such approaches, what are the things we are discussed till now, will be derived as a selfish routing. The concept of selfish routing. What is meant by selfish routing means the entire procedure, whether it may be routes they taken by themselves or overlay routing network, it will be based on the network transmission, their optimization only. For optimizing network itself it will be acting, but it is not pointing off the system environment. So if we take the entire system wide criteria, we are not getting the optimized host based or overload matrix. So for this we have to be applying, we want to prove some of the drawbacks, some of the results, some of the negative results which are given by in the selfish routing, as we can applying into the online market, something like online networks. So same thing we are proposing in this paper. We are using a game theoretic approach to investigate the performance of the selfish routing network in routing technique in internet like of environments based on the realistic topologies and traffic demands in our simulations. So what going to be derived in this line means I want to investigate the performance of selfish routing technique in internet like environments. So in internet I want to be check the performance of the selfish routing. For this we are following the approach is game theoretic approach. Game theoretic or game perspective approach we are commonly used for in the networking topology, where I can find the successive results by applying various combinations. We will see game theoretic approach how it will be look like, and finally we are going to be applying on top of the realistic topologies, how to find the realistic topology and how to find the based on the traffic demands how the simulation will be work on. Everything we are going to be seeing in this paper, and we show that in contrast to theoretical worst cases. So what are the worst cases we have find out in the process, as the selfish routing achieves close to optimal average latency in such environment. So what the thing is, whenever we are finding the in such environments like internet, it is very close to the optimal average latency only. It is not the high end. However, such performance benefits come at the expense of the significantly increased congestion on certain links. So congestion problems also will be increased. Moreover, the adaptive nature of selfish overlays can significantly reduce the effectiveness of the traffic engineering by making network traffic less predictable. So however we are using this kind of selfish overlays, selfish routing, we can significantly reduce the effectiveness of the traffic engineering by making the network traffic as less predictable. We are unable to less predictable means we are unable to predict the traffic. We are unable to predict the traffic entire the system. So based on his efficiency, suppose I am taking from A to B as the shortest path, I found some way, but in the way what are the traffic issues we have, we are unable to find out in sometimes. So those kind of things particularly we have to be find out, majorly we can find out easily in the internet kind of big networks, realistic data networks. So all these things we have to be discussing very in depth with an example of prediction techniques. This is about selfish routing. We have given the clear idea about that. So that is all about selfish routing. We have a lot of things to discuss. So what are the benefits of selfish routing? Use it to reduce the latency, increase the throughputs in the network. If you want to get the highest throughputs in the outputs in the network, then I can use this. Not cost oriented means much, it's not the things, it is economical only. Reduced administrative costs. If you want to be engaged the administrative activities in over the network, the administrative cost is also be less. Lower error rates. If you want to be talk about the error propagation, the error rate is also be very less. And increased productivity. Whenever we are talking about the productivity, obviously by the end everything will be think about the productivity only. So the productivity also be increased, and better services to the clients. Whenever you are talking about the client, it is giving the highest services range and it will provide the high solutions. whatever the network level routing, whatever the till now we are using, what is the drawback means the routing hierarchy is very tough, and the policy routing, equipment failure and transist instability, slow reaction to the network congestion. Whenever we are talking about the network congestions infrequently into the data world, the reaction may be slow. So for this kind of things will be happen as the limitation to the existing system. As the proposed, we already seen that as the proposed we are generating selfish source routing and selfish overlay routing. As a selfish source routing means in generally, however, the data will be platform itself. As the selfish overlay routing means we are giving one more third party help overlay network, so it will guide you that entire transformation. So all these things will be maintained in the part of two types, source routing and overlay routing. Check out what is selfish source routing. We have two types now, selfish source routing and selfish overlay routing. Check out what is selfish source routing. The source of the traffic makes an independent decision about how the traffic should be routed. The source can directly choose the route path. So in the selfish source routing, the source will automatically take a decision by itself how to transfer the data in an effective manner. Everything will be taken by the itself only. Selfish overlay routing. As a selfish overlay routing, sometimes we have to be controlled. So someone will control how to direct, how to transfer the data. In similar to source routing, the traffic source route controls the source. The end users often have the complete routing control. That is, source itself have maintained the routing table and they send the packets from source to destination. So itself it will be having the direction. It is very similar to do that, but the controls the entire routes. What are the things we are having with the issues, problems? Main objective. These are the hardware specification, hardware requirements. Software requirements. We given the some of the environment. Software environment means some of the technology description, what are technologies we have used, all the technology description we have provided. You can also be find the people who are unable to find out means they can be find out the technical part also. What is host, what is portal, what is subnet, what is TCP, what is the diagram detail, the diagram like IP routing, source routing, 3 only. You can also do that data image so overlay or source rating. Based on the levels we have derived the data flow also. Source, the root node, the file transfer, the destination, and acknowledgement sending the root node and the source node. Where the source is also finds the latency to the chart. We're taking this latency and I'm generating a chart also. The report chart is nothing but a report. UML diagrams, testing and test cases, implementation with the source codes, the sample screens as we have given in the end. This is what the home page where I can be execute IP routing, selfish source, selfish overlay, and comparison chart. We have three routings: internet protocol routing, selfish source routing, selfish overlay routing. Finally, if you want to compare means we will click on the comparison chart. Help as how to maintain how the network will be transformed and how the options will be executed, and the displacement will cancel will like as a cancel. This is what the IP routing. Okay, where the I am entering the destination and the file path. I can browse from the file path so that I can be give the some average latency also, how the latency will find out, and I can be click on the send. The data will be transferred to the successful the BCT9 destination. Now I am checking from the BCT9 to source to destination how the transmission will be happens. Or else source selfish routing, selfish source routing, how things will be happen, the destination and file. We can also click the source and latency. We are having the less latency, and routing nodes we have to find out. So I can be check the from sender to receiver. I can transfer the router I taken as a BCT9. So based on the route, the route also will be taken by the decision taken by the source only. As the source overlay routing, check out. Based on the overall network, on top of that it will take a decision and it will transform the data. This is what the comparison chart. We have what are the things we have done: IP routing and selfish source routing, selfish overlay routing. Among three, which routing has the highest latency? Means the latency will be high for IP routing and selfish overlay routing by comparing with the selfish source routing. Selfish source routing has a very less latency by comparing with the selfish overlay routing and IP routing. This is for the conclusion we want to be prove it. Some of the sample code we kept. All the things we used is swing. That's all about that. IP routing, selfish source routing, selfish overlay routing, comparison chart. Self-interested routing in online environments, how it behaves, how the things will be happen. We just implemented that technique into the online networks, and we are executing the status, whether it may be good or it may be bad or everything we are going to be find out.